All right, class, so we're just going to quickly go over 7.1 sampling distributions. Once again, this is a assignment you must complete before you come back to me on Monday on January 9th. I hope all of you had a great Christmas break. This is going to be really quick, so I just want you to have your guided notes right now for Chapter 7, and I want you to follow along. So at the very top, we're just going to revisit an activity we did a while back on the Gettysburg Address, right? So if you recall what we did, the goal of that, right, was to estimate the average word length. That's what we were trying to find. Because you guys picked like a sampling of 5, right? And we're trying to find the average word length of one of the words in the Gettysburg Address. When we did this, we attempted by sampling 5 words. And you did this randomly, right? Because that's what we had talked about. There are two terms that we talked about that were very important. One was called a statistic, and the other was a parameter. So a statistic is basically computed from a sample. And the notation we use for that is X bar. And that's what we had talked about a while back. A parameter then comes from a population. And then that is represented as mu, or a mean. So that's the difference right there. When we talk about a statistic, we're saying that this is coming from a sample, of the population, right? The entire population, is what a parameter would be. When we do this, we will always use a statistic, to estimate a parameter. So that's kind of the general thing that we talked about during the Gettysburg Address, right? Every time in class we've looked at statistics, that we are taking from a parameter, which is a general assumption of the population, right? And we're trying to make that assumption by taking a piece of that population, So, for example, right, if we were to draw a picture of this, I would have my sampling distribution like this. I'm just going to draw a dot plot real quick. I would just label these, right, 2 through 7. And then I'm just going to put a bunch of dots here. And this would have been my sampling distribution of X, right? So this is a picture of what this would look like, right? So this is my sampling distribution of X bar, And let's say I computed this and the mean ended up being 4.8, This would be coming from my parameter, When a statistic consistently overestimates or underestimates a parameter, we say that bias is present, and that's what you should fill in your guided notes, right? So when that happens, we know that bias is present in the sample. Bias is usually a result of poor sampling bias, or poor sampling design, you will say. And that makes sense to us, right? If we talk about how something is designed and we're sampling that design, right, bias will be introduced if it's very poorly operated, right? And that's what will happen, So when we did the Gettysburg Address, we tried to eliminate bias by using a true, simple, random sample, right? The first time we did the Gettysburg Address, everybody kind of picked the 5 words, right? And you picked on your own. But then what we talked about was that it wasn't random, So we weren't able to do that. So instead, right, we had to actually use a simple random sample to come up with the best possible 5 words, right, of the Gettysburg Address, So you can go and write that in, right? We had to use a simple random sample, right, and we used table D. So when we did this, right, here is an example of our picture again. This is what you're going to draw in. So I'll label this 2 through 7. Just going to draw my dots here. And from this, right, we found the mean. And the average word length, ended up being 4.28. So a true simple random sample using a random digit table, right, is what we had done to eliminate that bias, How can I make the sampling distribution better? Well, I need a higher sample size, right? We talked about how we picked 5 words at length for the Gettysburg Address, but then we extended it to picking 10 words, 15 words, 20 words, right? If we picked more words, right, then this would result in a higher sample size, and that's what you're gonna write down there, okay? Because higher sample size, we said, right, reduces the variability of the sampling distribution. Okay? And these are all terms that we talked about before, right? When we saw this in our earlier chapters and we were doing the Gettysburg Address, right? But we know that if we want to make this more accurate, it's got to be random, right? We have to have a higher sample size, and then we need to reduce variability, okay? So in summary, right, what makes a statistic a great parameter? Okay, there's 2 things, right? So what makes a statistic a great parameter, meaning what is the sample that we're taking out of the population that makes it so great? Well, the first thing is low bias, okay? The less bias we have, the better, right? Because that eliminates that confusion for us. The second thing that we said that was low variability. If we have low bias and low variability, right, then that means our statistic that we are sampling from the population is a good parameter, right? So that's what we saw a while back, okay? And that's pretty much it, right? I want you to fill in all those guided notes, okay, for the very first page. When I see you the next day, after you complete this video, we're going to start by going over some stuff on the next page, right? So we're already kind of spilling over into 7.1. We're going to be looking at sampling distributions, okay? Hope you guys had a great break. Please make sure you fill this out. If you have any questions, please email me. We'll see you guys soon. Goodbye.